Session 9, Waves. State the wave equation and give the units. Speed equals frequency times by wavelength. Speed is in meters per second, frequency is in hertz, and wavelengths in meters. A wave has a frequency of 3 hertz and a wavelength of 0.6. What's its speed? So speed equals frequency times by wavelength. So that would be 3 hertz times by 0.6 meters, 1.8 meters per second. A wave has a speed of 3,000 meters per second. If it's got a frequency of 10 hertz, what's its wavelength? So let's rearrange the equation. Wavelength is going to be the speed over the frequency. So that's 3,000 divided by 10. That's 300 meters. A wave has a wavelength of 3 times 10 to the 8 meters per second. That's not a wavelength, that's a speed. If it has a wavelength of that many meters, what is its frequency? So rearranging the equation, frequency equals speed over the wavelength. So that means 3 times 10 to the 8 meters per second divided by 7 times 10 to the minus 7 meters. And that comes out as 4.2857 times 10 to the 14 hertz. So that's like 4.3 times 10 to the 14 hertz. How could you measure the velocity of sound in air? So speed equals distance over time. Right, you'd have to get a rather large distance, say 500 meters apart, 400 meters apart, something like that. Have one person standing there with something that's going to make a noise, like a gun, or one of those sort of clacker things. And the sound will travel that distance and have someone measuring when they hear the sound. So from when they see the clacker, clack, start your stopwatch, the sound will travel, and when you hear the noise, stop the stopwatch. So you'll have the time that it took the sound to travel that distance. So you just do speed as distance divided by time. That's a common question. How could you measure the speed of ripples on water surfaces? Well, that's the same as this one here. Write a brief description for the core practicals we did on waves with the ripple tank. So the ripple tank is basically just a tank with a plank of wood at the end on a dipper, and this plank moves up and down and dips into the water, and it produces water ripples. That's why it's called a ripple tank. Boom! Now, you can, to get the speed, do the distance divided by the time. So if you know the distance that it takes, so put a little ruler there, watch the wave as it comes out, and you'll be able to see the distance that the wave's travelling. So that's your distance. And if you time how long it takes the wave to travel from here down to here, then that's your time, and just do speed as distance divided by time. Now, to make it easier, you could film it on your mobile phone with a ruler in the shot, and then you could just pause it. You could play it slowly. The phone will tell you what the time is, and you should easily be able to work out what the distance is that it's travelled. That's one way of doing it. Another way of doing it would be The wave speed is the frequency times by the wavelength. So again, using your mobile phone to time it, see how many waves come out, perhaps in 10 seconds, and just say 30 waves came out, but that was in 10 seconds. So that means you're getting 3 waves in 1 second. And that's what frequency is, how many waves there are in 1 second, how many waves there are per second. Now, and then just get the wavelength. It would just be, once again, put a ruler there, get your mobile phone to film it. You just need to measure the distance between one wave and the next wave. Or, once again, to make it more accurate, how many waves have I got here? There's 1 wave, 2, 3, 4. So I could just measure that total distance and then just divide that distance by 4, and that'll tell me what the wavelength is. The wave of one, the length of one wave. That's the wavelength. Metal bar and hammer. Right, the way I do it, have a little speaker here. And have a little speaker here. And you'd have to attach it to the end of the rods. Get a hammer, hit the end of the rod. That vibration gets picked up by this microphone. Did I say a speaker? Get a microphone and another microphone and put it on a timer. This microphone, when it hears the vibration, when it picks up the vibration, that starts the timer. The wave travels down through the metal bar. This microphone picks up the vibration and stops the timer. Simply measure the distance. Measure the length of the metal bar. That's your distance. And this timer will tell you what the time was, and do speed equals distance divided by time. Happy days. Earthquakes cause a sea wave. The sea wave travels 26,400 meters in 2 minutes. Calculate the speed of the wave, use this equation. So the distance is that. The time, it's 2 minutes to do 2 times by 60 seconds, and that equals 220 meters per second. The wave has a frequency of 15 hertz. Its wavelength is that, 125 meters. Calculate the speed of the wave, state the unit. Speed equals frequency times by wavelength. So that's 15 hertz multiplied by 125 meters. And that comes out as 1,875 meters per second. The students produce a different wave. This wave has a frequency of 1.7 hertz and a wavelength of 8 centimeters. Calculate the speed of the wave. Well, 8 centimeters is 8 times 10 to the minus 2 meters. So 0.08 meters. Speed equals distance divided by time, but we can't use it because it's given us the frequency. So speed equals frequency times by wavelength. So that is 1.7 hertz times by 0.08 meters. And that equals 0.136 meters per second. Some students are investigating waves. They produce waves by moving a piece of wood up and down in a tank of water. Well, that's the ripple tank. The diagram shows the waves over a distance of 60 centimeters. State the number of wavelengths shown in the diagram. Easy peasy. So from there's 1, 2, 3, 4, 5. Boom! Calculate the wavelength of the waves. Right, 5 waves is 60 centimeters. 5 waves equals 60 centimeters. So 1 wave would equal 60 divided by 5, which is 12 centimeters. A man throws a stone into a pond. Devise a method of measuring the frequency of the waves. So the frequency is the number of waves per second. When you chuck a stone in the middle, you're going to get waves coming out like that. Film it with your mobile phone. time it for 10 seconds. Count how many waves there are. So if this was 1, 2, 3 waves, that would be 10 seconds equals 3 waves. So how many waves in 1 second? 3 waves divided by 10 seconds. That's 0.3 waves per second, which is 0.3 hertz. Thank you very much. I hope that's helpful. Bye for now. Want to see more videos like this? Subscribe to my channel, GCSE Physics Explained. Thanks very much, and bye for now. Work hard and be nice.